Hello, my little mathlets. All right, we are starting in the actual math book now. So let's take a look at what the first lesson is going to be. You should see something similar to this view in your side of the digital text. I know it'll be a little different, but you'll see the parts that I assigned to you. So I'm going to make you go through the Interactive Student Edition of Realize Reader. There are some things I want to go over here. You can look through all these essential questions and things, but you can do that later. It's going to tell you what we're going over. Cool. Just click Next to go through the lesson. And let's look at number lines real quickly, because this is important. So a teacher labels 2 points on a number line, and it asks you what are some methods for finding the distance between points A and B. And it's going to come up with all these. So you go in, I want you to write something in here to try to get an idea. All right, two obvious methods. One, you could just go and you could count, right? 1, 2, 3, 4, 5, 6, 7, 8, right? And we've got 8. So the answer would be 8. That's the distance between point A and point B. We're trying to find this distance right here between point A and B. And counting it, I got 8, but let's try another way of doing this. See, B is at 5, A is at -3. What happens if we subtract those from each other? So subtract the number on the left from the number on the right. And you go 5 minus -3 equals what? Remember that minus a negative is the same as going plus a positive. And you would end up getting 5 plus 3, 5, 6, 7, 8. Whoa, same answer. Okay, so what if we went the other way? What if we went -3? So what if we started with this number right here? We went -3 minus 5. We would get -3 minus 5, we would get equals -8. But we cannot have a negative number for a length. But that's okay, because you can always use the absolute value. Absolute value, remember, all absolute value means is if you have a negative number, you make it positive. So you can subtract either way, you just have to turn the negative number into a positive number and you get 8. So that's how I suggest you find distance on a number line. Just subtract one number from the other. If you get a negative, make it positive, and there is your answer. That way you're not sitting there. What if it was like, you were trying to find the distance between 150 and 237. You don't want to sit there and manually count. Cool, let's move to the next example. All right, they are wanting us to memorize these definitions. They're not as terrible as they look like, right? Okay, a point is, these are undefined terms because there is no way to prove that a point is a point. It is something that exists solely in your mind. It is just a construction of our brains that helps us kind of theorize how the universe works. So a point is a location and has no size, which is like super confusing, because if a point has no size, then how do we, but that has size. It's a mental construct. So please don't let that get too confusing for you. Just accept it. It's better if you just accept it. All right. A line is an infinite number of points on a straight path that extends in two directions. So a line technically has no thickness. It just goes on and on forever. That's all you need to know. A line is a freaking line, right? It's just this like infinite number of points, no thickness. It just goes through space. And it can go in any direction, go through any wall. It just goes on forever and ever and ever until the end of the universe. And a plane is the same thing. Well, it's not the same thing, but a plane is, you can define a plane with 3 points that are all on the same line on a flat surface. So that's just, think of a plane as a giant flat surface, like a wall, a ceiling, a floor. All of those could be conceptualized as a plane. Cool. Let me drag this whiteboard out of the way. Boom. Okay. Our next example here. All right. A segment is a piece of a line. All you need to know. A line segment is just if you take a line and you go, boom, put a point there, put a point there, label them X, Y. The segment is just that piece of the line right there. Okay. It would be segment X, Y. A ray, it gets, okay, cool. You know what a ray is? You think of a light bulb. So if we draw a light bulb here, boing, put little threads on it. Ray, think of like rays of light. they go in one direction, right? They start at a point and they go in a direction and they go forever until they peter out, right? So that is what a ray is. And it's a good conceptualization, right? A photon will go on forever in one direction, and it just lasts forever until it's absorbed or turned into some other form of energy. So this is a good way of conceiving how the universe works. A ray, just think of something going in one direction. Opposite rays, yeah, duh. You just draw a line and then these are opposite rays, right? Because they're going in different directions. And one of the most important is if you take two rays and you start them at this point and then you go ray, ray, and they go in different directions, guess what? You have an angle. And an angle can have a measure. Cool? Cool. Glad you understand. I'm going to try not making you take notes on this because I kind of want you to understand the concept more than I need you to know the actual names of these things. I just need you to know that you can understand how this works. Okay, so this is asking you to find ways of that you could find the length of segment CD, and then it gives you this way too long explanation of how to do it. Okay, remember there's two parts of it. All right. Referring to the figure shown, how can you find the length of AC? Well, like I said, it's better to just go 4 minus -3. And so if I do that, and why? Because D is at 4. Oh, C is at 1. Sorry, 1 minus -3. So C minus A, right? So if we do the math on this, 1 minus -3, we get 1 plus +3, 4. So the distance is, let's see if that's true. 1, 2, 3, 4. Yep, it's 4. Cool. So I put my answer as 4, check answer, boom. Count the units of distance, it's 4. Just a little subtraction. That's all you need. The ruler postulate is got to be, it's so obvious it's confusing. Every point on a line can be paired with a unique real number. All you need to know about real numbers is they're just numbers, okay? We're not going to talk about a non-real numbers like things like the square root of -1, which we're not going to worry about right now. All it says is that you can make a number, a thing corresponds to something in space. Okay, so you can pair a point with a number on a ruler. It just basically says that you can measure things. All right, so the distance between any points on a ruler is the absolute value of the difference of their coordinates. So remember what I said, absolute value is just taking a negative number and turning it positive. If you have a positive number, it stays positive. If you have a negative number, it becomes positive. That's all you need to know about absolute value. This is how do you find the length of a segment? Use the ruler postulate to find the coordinates. All it's saying is just read the coordinate. There it is. Cool. J is at 5. A postulate is a set. Yeah, okay, cool. That's all you gotta know. Neato. Segment addition postulate is another one that is just like sort of blatantly obvious to the point of confusion. Cool. All right. Get rid of that too. Seriously? Come on. All right. So the segment addition postulate. If I have a line segment and they're on the same line, guess what? They all add up. That's all we're saying here. So if this distance was 2 and this distance was 3 between these segments, what would the distance total be? It'd be that segment plus that segment. Oh, well, let's add another one. Let's make this one right here 4. What's 2 plus 3 plus 4? 4, 5, 6, 7, 8, 9. Then that would mean that the distance here would be 9. That's all it's saying. All it is saying is that you can add up segments. That's what the segment addition postulate says. And that's all I want you to know is you can add up segments on a number line. Cool. I want you to go through this every step. Protractor postulate Now the protractor, remember, is the thing for measuring angles. The protractor postulate says that you can measure angles with a protractor. That's all it's saying. Use this to measure an angle. Cool. All right, so we just go, what is BEC? BEC. That's how you do that, right? It starts at B, goes to E, goes to C. Just follow along. So whatever letter is in the middle is at the vertex of that angle, or the point where the angle has its little pointy part. And then follow along. So BEC, I see that it is, B is at 47 degrees, C is at 105 degrees. So 105 minus 47 is 58. And so that's what it says it is right there. Okay, cool. Shows you how to measure things on a protractor. That's all we're doing. The angle addition postulate says that we can add angles. So, as you can see, look, you even have a little protractor you can work with. But if that's 30 and that's 30, then they add up to 60. It's like the segment addition postulate. It's just like so obvious, it hurts. So if I've got two angles and they share the same vertex, right? So that means A, B, C, D. All right, so you give an angle a name like this. So this angle right here is angle A, B, D. This angle right here is angle D, B, C, right? D, B, C. And we add them up. So, and then we go, the big angle is angle ABC. So we know the angle ABC equals angle ABD plus angle DBC. That's what we're doing here. Okay, just adding angles up. Let's look at the next one. They're gonna give you this problem. Don't let this one confuse you. This has got to be like hands down the worst example I've ever seen in any math book for explaining that when you add two angles up, they equal a bigger angle. That's all you're doing. Cool. Okay, this is all about marking. If you do these little congruency marks, are just so that we can give each other notations, because we're not really actually drawing things at the exact same lengths and widths. That's not what we're doing. But if I have a segment and I have another segment and I want them to be congruent, remember, geometry, it's all in your head. All I have to do is draw this little hash mark. Book, book. Look at that. They're congruent now, which means they're the same. Congruent just means they're the same length or the same angle. It just means that they're a copy of each other. In geometry, it means that they're exactly the same. Maybe I want to differentiate, so I have like a couple more segments here, then I can do that. The two hash marks means that those two are congruent. So if I had a third set of angle segments, how would I show that these are congruent, but maybe these are congruent with each other, but not with these ones over here? 3 hash marks. That's it. Number of hash marks indicates whether they're related or not. Okay, if I'm drawing an angle, then if I want to indicate that it's congruent to another, look, I'm a terrible artist. I can't draw, but how do I indicate that I want these two angles to be seen as congruent, as the same? Boom. I put that little hash in the middle there, in the vertex of the angle. They are now congruent. That's just the way it is. That's how it works. And if I've got another set of angles, I can make those congruent by doing this. 2 hash marks, okay? That's all you got. That's what those marks are. I guess in this one they call them arc marks. Tick marks on lines, arc marks on angles. I don't care if you know the name, I care if you know how to use it. Using congruent angles and congruent segments, cool. I need you to go through all these examples. Go through them before you ask me questions, and I will be going over this in class. All right, essential question. How are the properties of segments and angles used to determine their measures? Oh, geez. Yeah. Do your best on that one. Cool. Remember that you click on these, you get more examples. These are great practice. I'm not assigning you anything out of these because they're too hard. I didn't like the book exercises for this one, so you got lucky. What I'm assigning is the reteach exercises because, like I said, you got lucky. I don't like these exercises, so we're not going to do them. But you are responsible for doing the reteach and build understanding exercise. And I said we weren't going to have cumulative tests, and that's still the case, but we will do lesson quizzes to give you an incentive to stay and pay attention to the lesson. So we're doing so that we're like testing our understanding in small increments. So there will be a lesson quiz at the end of the week, but I'll try to keep the stakes low, and you can use any notes that you take. I know that there will be questions in class. That's totally understandable and expected. So let me know what those, we'll find out what those are when we go into this later. This lesson went on a little bit long, but I don't know how to keep it shorter. I will see you guys on Monday. Have a great weekend. Well, have a great week because I'm not posting this till Monday, but I'll see you on Monday.